Hello, everybody, and welcome back. We're here. We've made it. We've pushed through the rest of the contest. Saw some interesting problems along the way, and we have arrived here at question 25, the very last question on the 2001 Gauss paper. That's the grade 8 Gauss, not to be confused with the grade 7 Gauss. You can look for that question 25 in another video. Grade 8 level contest here. So hopefully you've been following along. You downloaded a copy, tried the contest for yourself. And you've even given question 25 a go. I'm about to try it myself right now. And it says, Tony and Maria, I believe those are West Side Story character names, although I don't know if that's the inspiration. So Tony and Maria are training for a race by running all the way up and down a 700-meter long ski slope. Okay. They each run up the slope at different constant speeds. So I'd be tempted to say let T be Tony's speed and M be Maria's speed, but we'll see the rest of the question before we start coming up with variable names. Coming down the slope, each runs at double his or her uphill speed. So coming down, I guess Tony would be traveling at 2t, that sort of thing. Maria reaches the top first and immediately starts running back down, meeting Tony 70 meters from the top. When Maria reaches the bottom, how far behind is Tony? Okay. So this is a question involving speeds, which we don't know, some distances that we do know, and some times that we don't quite know. So, like I said, we're probably going to let T be Tony's speed and M be Maria's speed. So coming back down the hill, 2T would be Tony's speed, and 2M would be Maria's speed, because coming down the slope, it says they run at double their uphill speed. Okay. And in terms of times, because for these sorts of questions, you got to nail down times. You might not actually be able to figure out their specific speeds, but there might be enough to sort of get a relationship between their speeds. We'll see. But so we got variable names for their speeds, but in terms of specific times, we have the start time, where we know Tony and Maria are together. And we don't know, unless we figure out Maria's speed, we don't know how long it takes for her to reach the top. But once she does, she comes back down and Tony and Maria meet again 70 meters from the top, so 630 meters from the bottom. So that's an important time, because that's the only other time we have distinguished. And then the last time that we'd be concerned with is when Maria reaches the bottom. So that time is important. And we're asked how far behind is Tony. So hopefully he's reached the top and is coming down as well. Okay. So let's jump into it and actually start doing some math. Okay. So I'm going to draw some pictures illustrating my times. So at the very start time, so let's say 0 seconds, we'll say they run meters per second. I don't think we'll be doing this question in meters per hour. So we know 700 meters. Thinking nothing of this right angle triangle, I'm just talking about a ski slope here. And we know that Tony and Maria start here and they're going to run up the hill. Then eventually, at some unknown time, let's call it x. So after x seconds, Maria has gone up the hill, and she's coming back, and it's 70 meters from the top. And Tony has gone up 630 meters, and they meet here. And then finally, at the very end, I don't know if we'll need this time, but we'll call it y just in case. Maria has gone up. She's come all the way back down. And Tony has likely started to come back down. And we're just wondering how far behind is Tony, so we're curious about this time, or this distance right here, which we'll put in blue. So blue, that'll be our final answer, whatever that is. Okay. So we'll let T be Tony's speed, in meters per second. And I don't think this M will get too confusing with meters per second, but do we want to change it? No, I think we'll be fine. If you get confused, if you have a little m and you got meters in there and you get confused, that's okay. Just pick different variable names. Actually, let's make it n for Tony's speed, because that's the next consonant, and r for Maria's speed. And that way we won't ever get confused here. Okay. So, what have we got here? So after x seconds, Tony, not tonally, Tony has gone 630 meters. And so if we want, so it's a nice little formula we'll put in a box. Distance is speed times time. So 630 meters is x seconds times n meters per second. Okay? So now we have a relationship between x and n. That's good. Now what about Maria? Because her story is a little different. And we might actually be interested in adding another time, let's say z seconds, that it takes for Maria to reach the top. Yeah. So I wasn't thinking of that one when I was talking out loud earlier, but figuring out when Maria reaches the top might be a good thing to work on. So then at that point, she's gone 700 meters, and that's going to be her speed, which is r, times the time, which is z. Okay. So she reaches the top, and then a few seconds later, at time x, she has now gone 70 more meters. But she's not moving at r, she's moving at double her speed. So now she's moving at 2r meters per second. She travels down the hill 70 meters and meets Tony. Okay, so she goes 70 meters, and that's 2r times x minus z. That's the time it takes her to do that. Okay. It'd be really nice if I knew z. Even if it's just in terms of something like x or r. So I noticed that I have this equation involving Maria's speed r, and it's got 70 meters, and I also had that other equation on the back, on the other page, which was 700, is r times z. Well, if I multiply this equation by 10 on both sides, I'll get 700 meters here. And I'll get r times 20 x minus z, multiplying by 10 on both sides there. So, rearranging this second equation, z is 700 over r, which is the same as rearranging this first equation, that's 700 over r is equal to 20x minus z. So 20x minus 20z is equal to z. 20x is, bringing this one over, we get 21z. So z is going to be equal to 20 21ths of x. Okay? So let's plug that in. I don't know whether or not that's actually going to... Well, it'll give us an equation in terms of r and x. Okay? So let's plug that in so 700 meters is r times z, which is r 20 over 21x. So 20 over 21 times 700 will be r times x. Okay, and if I just grab my calculator, 700 divided by 20 is 35 times 21. So we should be looking at 35 meters is r times x. Okay. So, what has that got us? Well, now we have an equation in terms of a known length, a specific time x, and Maria's time. And we also have another equation involving a distance, Tony's speed, and a specific time x. So what we could do is we could find a ratio between r and n. I don't think we'll actually be able to solve for r and n, but we can certainly figure out how much faster Maria moves relative to Tony, and that might just be enough to solve the question. So let's divide the first equation by the second one. So r over n, these two x's cancel each other out, so we're going to divide. And 735 over 630, well, both of them have a factor of 35 in them. So we're looking at 21 over 18 or 7 over 6. So if we wanted to say it, we could rearrange and say r is 7/6n. So Maria is moving 7/6 faster than Tony. Or Tony is 6/7 as fast as Maria, however you want to write that. Alright. So, ultimately we're trying to find how far behind Tony is when Maria reaches the sort of the ground floor, the starting position. Now it took her time z to reach the top, which was something we had to introduce. How long does it take her to go from the top all the way down to the bottom again? Because remember, she's moving at twice her normal speed when she comes down. So let's figure out y. Again, we probably won't get an actual definite value like y is 90 seconds or something like that, but we'll be able to get it in terms of some of our known values, and hopefully enough values will come together. We'll get a nice relationship, and maybe we can work out how far behind Tony is. So let's find y. So it takes her z seconds to reach the top. So So it takes her z seconds to reach the top. And then coming down again would take her a half z. So y is the time it takes for her to reach the top plus the time it takes for her to reach the bottom. And if we put that all in terms of x, and why not? So it's going to be 30/21 x. Because remember, z was 20 over 21 x's, and having that, we just change the 20 into a 10. Okay. So after 30/21 of x seconds, Maria has reached the bottom of the slope. Okay. So now our question is, how far behind is Tony? Well, Tony, as I keep saying, has likely reached the top and is starting to come down. So how long does it take Tony to reach the top? There's a couple ways we could figure this out. We know his speed relative to Maria, and we know how long it took Maria to reach the top was z. But something else we could do, we know that he goes 630 meters in x seconds, and he's moving at speed n. So if I want to get 700 out of here, I need to multiply by 10 over 9. So multiply by 10/9 on either side, and we'll get 700 is 10/9 n times x. The speed is constant, so this is actually going to have to be n times 10/9 x. So 10/9 x seconds is how long it takes Tony to reach the top. And so he reaches the top, and up until 30 over 21x, that's how many seconds he has to be running down. So how long has he been moving at double his normal speed? By the time Maria reaches the bottom, well, for this amount of time. Let's figure out what that is. Again, it'll be in terms of x. So we can take the copy of x out, and now it's just a fraction that we need to work with. Let's get a common denominator there. I'm seeing a 3 and a 7 here and a 9 here, so let's make everything over 63. That'll be 60, no, not 60, 90. 90 over 63, and then here we have 70 over 63 x, and then that's going to be 90 minus 70 is 20, so 20/63 x. That's how long Tony has been running at double speed. He's been running down the hill for 20 over 36, or sorry, 20 over 63 x seconds. So he has covered a distance of, let's see, so for him, n is 63 meters over x seconds. And no, he's moving it double n. So his double speed is 2n. He covers 630 times 2, 100, which is 1,260. So every x seconds he goes 1,260 meters. Well, he's been running for, so distance again is speed times time. Well, he's been going for 2n, and it's for 20 out of 63 x's. But 2n is 1260 over x. And so here, the x's are going to cancel each other out. So 1260 times 20 all over 63. So let's clean that up a bit. That's going to be 20 times 20. So he's going to have gone a distance of 400 meters. But that's coming down the slope. So he'll have come down 400 meters. The slope is 700 meters. So he is 700 meters minus the 400 he has already come down, 300 meters behind. And I do hope that's one of the answers, otherwise we're going to have to go back and double check our algebra. Although if we have time, we should be double checking our algebra anyway. It's an important question, it's the last question. 140, 250, 280, there's 300, and 320 was the other option. So I'm going to confidently say it's D. Tony is 300 meters behind Maria. All right. So that nicely wraps up the 2001 Grade 8 Gauss paper. It's an interesting little contest. I enjoyed it. Hopefully you guys did as well. And if you're eager, you can start watching, a more difficult contest. I'm going to go into the 2001 Pascal. That'll be what I'm putting up next. Or, stay tuned. I'm going to sort of loop back around and take a look at the 2002 Grade 8 Gauss. So if you're preparing for a Grade 8 Gauss paper coming up, by all means, watch the 2002. Of course, I've already done the 2000 Gauss paper, and now we've finished the 2001 together. And we're just going to keep going. So thank you for watching. Hopefully you've enjoyed this contest, and hopefully you've enjoyed almost all math contests. I mean, they're fun. Math is fun. And I'll see you guys in the next video, whichever one it happens to be.